Let's talk about absolute value, and we are going to work with solving absolute value equations, and we are going to talk about absolute value inequalities. So, first thing, absolute value represents the distance from 0 on a number line, and it is always positive. Okay, so how do we solve this then? Well, let's think for just a moment. What is the absolute value of 5? And that would be 5. On the flip side, what is the absolute value of a negative 5? That's still going to be 5. So the absolute value of a positive or a negative is going to be positive. So when we're solving equations, we need to keep that in mind. So 5m plus 7 is equal to 22. The absolute value of the inside could be positive or negative. So what we need to do is take the inside, 5m plus 7, and we need to set it equal to positive 22, and we need to set it equal to negative 22. Because the inside can be positive or negative, it's still going to bring us an absolute value of a positive 22. So then you just need to solve. So 5m is equal to 15, so m is equal to 3. And in this one, we're going to have 5m is equal to a negative 29, so m can also equal negative 29 fifths. And that's it. So final answer, x is equal to 3 or negative 29 fifths. So that's it. That's all you really have to do for absolute value, but you must get the absolute value by itself first. So in number 2, the first thing you need to do is subtract 16 from both sides. And that'll give you 4 times the absolute value of 3m plus 1. And that would be equal to a negative 8. And now we're going to divide everything by 4 to get the absolute value by itself. So we have the absolute value of 3m plus 1 is equal to a negative 2. And now you're going to try to solve, and it's not going to work out. And here's why. We just got done saying the absolute value of a positive is always positive. And the absolute value of a negative is always positive. The absolute value of nothing is ever going to be negative. So as soon as you see that an absolute value is equal to a negative number, it's just no solution. Cannot be done. All right? So number 3, why don't you go right ahead and pause the video for number 3 and give this one a try on your own to see if you get it correct. If you got 6 and 12, you are good to go. First thing you had to do is add 4 to both sides, then divide by a negative 2. So you get the absolute value of 9 minus x is equal to 3. And that's when you take the inside, set it equal to the positive and negative, and solve, and you are good to go. All right, so that is absolute value equations. The next thing we're going to do is talk about absolute value inequalities. So inequalities we've already talked about, and or statements are going to be involved. Here's how you can tell the difference. First of all, you have to look at the sign of the original problem. This says the absolute value of 23 minus 2x is less than. Whenever it is less than, I want you to think about less than. Every time it's a less than absolute value inequality, it is going to be an and statement. Whenever it's greater, think about it like this. Greater. Okay, so whenever it's a greater than or a greater than equal to, it is going to be an or statement for the inequalities. Okay? Otherwise, we start by saying take the inside. 23 minus 2x is less than 17. And 23 minus 2x is switch the direction of your sign and make it negative, greater than negative 17. And now you just solve each of them. So we have our negative 2x is less than negative 6, so x is greater than 3. Remember to change the direction of your sign again when you divide by a negative. And this is going to be a negative 2x is greater than a negative 40. So x is less than 20. And to sketch the graph, all we have to do is have our number line where we have our 3 and 20. And the first thing we have is x is greater than 3, so that's open circle above 3 going to the right. Less than 20, so open circle going to the left. And this is an AND statement, so we just have a barbell above both of them. And that's it. So why don't you try number 5? This is a greater, so make sure you use an OR statement for your inequality. Pause the video, give it a try, see if you can get it on your own. If you have x is greater than or equal to 1/2 or x is less than or equal to -3, you are good to go. So we have one more thing to talk about, and that is model of tolerance. So model of tolerance is basically we can have different models. So this first one is actual minus ideal is less than or equal to tolerance. And what this can be used for is a problem like this. So a manufacturer has a 0.6 ounce tolerance for a bottle of salad dressing advertised as 16 ounces. Okay, so it's going to be impossible to make every single bottle 16 ounces exactly when it's being made in a factory at high speeds. So there has to be a, error, so to speak. So we're going to write and solve an absolute value inequality that describes the acceptable volumes for a 16-ounce bottle. So that would be actual minus ideal is less than or equal to the tolerance, okay? So you have to take what you know, and we don't know what the actual is for every single bottle that's ever made, but the ideal is a 16-ounce bottle, and that has to be less than or equal to a tolerance that they have set as 0.6 ounces. And now you just have to solve. So we have x minus 16 is less than or equal to 0.6, and x minus 16 is greater than or equal to -0.6. And then you just have to solve by adding 16 to both sides. So we're going to have x is less than or equal to 16.6 and x is greater than or equal to 15.4. So the acceptable range for a bottle of salad dressing is going to be anywhere from 15.4 ounces to 16.6 ounces. Anything outside of that range would be denied and would not be sold. All right, so that's an idea of what tolerance is. So here's number 7. I'm going to ask you to, of course, pause the video and try to do this one on your own. Read through it carefully and see if you can figure out what's going on. First of all, you should have the average of extremes is 4.5 feet. Okay, an average is just the high plus the low divided by 2. The average tolerance is the average minus the extremes. So 4.5 minus 3 is equal to 1.5. If you did it the other way around with 6 minus 4.5, you're going to get the same thing. So our inequality is the height minus 4.5 has to be greater than 1.5. And then all you have to do is solve both of them, and you are going to end up with the height has to be greater than 6 or less than 3. And that's it. So this is Longo, and I'm out. See you. Bye.